Hello everyone, welcome to this online teaching and learning portal. It's me Durga Dakal, Kathmandu University full-time faculty of business mathematics. This is our unit 4 integrations and the net contact hour of this unit is 7 hours. This tutorial video is designed under the Kathmandu University course syllabus for especially BBIS students. This is the first video of this unit integration. University allocates 7 hours of curricular practices for this unit, but don't worry, we are using online pedagogy or teaching and learning practices, so you can engage more hours. Before starting integration, the basic concepts of integrations we discuss, like what it is, why we study, or for what we need the concept of integrations. I discuss little bit. Further more information, I suggest you to go through your textbooks and different online learning portal. First of all, let's talk about what is integral. It is all about the collection. It is the sum of areas of rectangles in bounded regions, and we apply these integrations in different dimensions, the dimensions which is particularly related with the bounded regions. And basically simple arithmetics can determine the area of circles, square, rectangle, triangle, or any regular polygon sets. But what about the area of bounded regions? For this exactly we use integrations. Similarly, we use the concepts of integrations to compute the total deflections of beam due to the bending stress and the distance travel underwater by a submarine, the electricity bill for a company that consume power at different rates, and convert into original function from the marginal function. So let's begin. First of all, we study the indefinite integral. Indefinite integral, indefinite integral. Mathematically, it is symbolized as BBIS, that means SUM sum. Only we use these symbols to use integral when we compute the problem of integral. Okay. From the definitions, what we have, how we can define this integral. From the definition, mathematically we write f prime x is equal to fx. What does it mean? Here f prime x is equal to fx, or in another symbolic form we can write as well f prime x dot dx is equal to fx dot dx. What we did here, we multiplied this dx in both sides into these first equations. Okay, here f prime x dot dx is the differential of f, is the differential of f. Okay, differential of f. So we can write finally df, that means f prime x dx is the differential of f. Df is equal to function of x dot dx. For an example, we can see here. Now let's take an example. Okay, if fx is equal to example, if fx is equal to 3x square. Okay, the derivative of fx is equal to what? We already discussed about the concept of derivative. The derivative of fx is equal to That means f prime x is equal to 3 2s are 6x. Okay, and what about the antiderivative of this 6x? Here 3x square is here 3x square is an antiderivative of 6x is an antiderivative of 6x, sorry, 6x. Okay, what we can see here, as you can see here, now let's take another example. Okay, as you can see here, now let's take number 1, d 3x square plus 10 over dx. What is the derivative of 3x square plus 10? Obviously, you can say the derivative of 3x square plus 10 is equal to d 3x square over dx. Distribution property I use here. You can understand on this way as well. D 10 over what? Dx. Now you can see here the derivative of this part is 6x. We have the formula of derivative we already discussed about. Dxn over dx is equal to what we can write here, n x n minus 1. That means n belongs to the power and x is base. So power is 2, base is 3, base is x and coefficient is 3. So 3 2s are 6x, and the derivative of constant is equal to always 0. This is the another formula we already discussed about it. 6x plus 0 is equal to, finally we have 6x. Similarly, we can write here what is the derivative of 3x square plus any number, any constant number. We can take any constant number like s plus, or we can take here minus 100 as well. On that conditions, you can guess what is the derivative of these functions. Obviously, the derivative of this function is as well 6x. So when you talk here about the integrations, here we have a constant form also. So the derivative of this constant is always 0. Please keep remember this concept into your mind. So we know that the indefinite integral of 6x, the indefinite integral, indefinite integral of 6x with respect to what variable we took here, with respect to x, because in calculus we have two variable here according to our course curriculum. This is x variable, this is y variable. Okay, and the functions what we say, that is fx. Okay, the function curve is fx. So 6x with respect to x, that we can mathematically represent here indefinite integral. The symbol is indefinite integral. 6x dot dx is equal to 3x square plus c. Okay, here we have some basic formula about the integrations. Before introducing into the exercise, before zoom into the exercise, we have to follow some formulas of integrations, some basic formula of integrations. If we clearly understood about the formula, then we can solve the numerical problem. Okay, now let's talk about the formula. Some basic formula of integrations. Okay. Basic formulae of integrations. Okay, I think you guys already study this basic formula of these integrations in grade 11 and 12 as well. First of all, the formula number 1 is integrations of 1 dot dx is always x plus c. Oops. Your x is almost plus. Okay. Uh, sorry for the disturbance. X plus c. When we have the constant, or when we are taking the integration of the constant, then the integration is always the respective variable, which is x, which comes together with this d. So x plus c. And the formula number 2 is integrations of x power n dot dx is x power n plus 1 over, this is n, seems like h, but this is not h, n plus 1 plus c. Now this formula is not enough, is not sufficient. Why? Because when we put the value of n is equal to minus 1, then what happened? Then the structure of this function is not look like that. That means if x is equal to, if n is equal to minus 1, then it became 1 over x. So it looks like the different function. So we can say here n is not equal to minus 1. By taking the idea of these two formula, we have one questions, okay, which I took from the exercise of your textbook, exercise number 14.2. You have an assignment at the end of this video. Exercise 14.2, question number 5. The question is 5 x power minus 7 dx. Okay, this is the question. This is the symbol of integration. So how we can solve these questions? By using these two formula number 1 and formula number 2. This is constant, so we can take out this constant out of this integration symbol, 5 and x minus 7 dot dx. Here the power is in minus form. Okay, so what we can write here, this function is, now this function, this part is similar as formula number 2. We can see here, okay, similar as this formula. So how we can represent once again, when we delete integration x power minus 7, we can use here bracket. When we remove the symbol of integrations, then not need to write the symbol, the x power, what is here, n plus 1, n is minus 7 plus 1 over minus 7 plus 1. Okay, again plus c, constant. So finally that is 5 x power minus 6 over minus 6 plus 5c. What about this 5c? 5c is again c, because this is the constant. 5c, 10c or whatever we can write on this way. So instead of this 5c, we can write here a single c. So the final answer of this problem is 5 over x power 6 minus, or we can write this way, 5 over minus 6x power 6 plus c. Okay, now let's move to the others formula as well. I can use on this side. Okay. I think this part is not necessary for you, so I am erasing this part. Okay, hope you all are understanding. If you don't understanding, then you can pause this video and go back, listen again, surely you will understand. Okay. Okay. Second formula, third formula, formula number 3. That is integration. What about the integration of 1 over x dot dx? That is log x plus c. Okay, and formula number 4, integration of 1 over a plus bx dot dx. Then the formula is, now we have to see here the coefficient of x. The coefficient of x is, you can see here, the coefficient of x is b. So 1 over b log, the same things we have to write here. 1 over b log, what is the function? A plus bx plus c. By combining these two formula, we have another problem. Example, the question is, I am taking these questions from a textbook, different textbook. This question is not in your textbook. So integrations 1 over 2x plus 3 dot dx. Okay, what about the solution of this problem? Simple. The coefficient of x is 2. We always take 1 over 2 at the beginning part and log 2x plus 3. Done. Okay, and the final formula of this integration, indefinite integration, is formula number 5. Not final formula, I think it's second one or third one. Integration a plus bx power n dot dx. What is the solution of this problem, this type of problem? So we have a plus bx. Whatever we have here, we have to write this part in the numerator form, and the denominator form, what we have to write, power we have n plus 1, and the coefficient of x is b. So multiply here b in denominator, n plus 1 plus c. Once again, when we use the numbers of the n is in negative form, then it doesn't work. That is, n is never minus 1. Okay. So what happened when we use here n is equal to minus 1? When n is minus 1, then it goes up to the formula number 4. Okay. So I think these are very simple, and the questions for this formula is integration 1 over root under 2x plus 3 dot dx. What is the solution? Integrations, we can rewrite here 2x plus 3 power minus 1 over 2 dot dx. Okay, and then what we can write again, we can compare these things into this number 5. Okay, so it looks like 2x plus 3, the function 2x plus 3 is in denominator, and n plus 1 is minus 1 over 2 is n plus 1, and in the denominator form the coefficient of x is 2 times n plus 1, that means minus 1 over 2 plus 1 plus c. It looks like, when you solve it, then it looks like 2x plus 3 power 1 over 2. Okay, minus 1 over 2 plus 1 over 1 is equal to, when you take the LCM of these two, denominator is 2, 2 cancel, 2 divided by these 2, you will have 1, and the sign is here minus plus 2, 1 divided by this 2, the quotient is 2, 2 times 1, 2. So it is finally 1 over 2. Okay, 1 over 2, and whole over 2 times 1 over 2 plus c. These two are cancelled, and finally we have 2x plus 3 power 1 over 2 plus c, or you can write here under root 2x plus 3 plus c is the answer. Okay, now we will have another final one, formula, that is the integrations of exponential function. Integration, formula number 6, integration of ex dot dx is equal to same ex plus c. And what about the integration? This is not the formula, the basic formula is number 6, ax dot dx or e minus ax dot dx. Then the formula is e minus ax over minus a plus c, or integrations e ax dot dx is e ax over a plus c. Okay, now we will have one final question from that exercise 14.2. Sorry. What is the integrations of, this is the questions, what is the integrations of ex plus e3x over ex dot dx? Okay. So we have these two formula. By the help of this formula 6 and 7, we can find out the solution of this question. First of all, we have to apply the distributive properties of these functions, where integration, this is indefinite integrations, only the symbol big S is in indefinite integrations. I will talk on next video what is definite integration and what is indefinite integrations while we entering into the definite integrations. Okay, so when we apply the concept of distributive properties, so ex over ex plus e3x over ex dot dx, and then what will the next step? Integrations 1 plus, when the same bases are multiplied, power are added, when same bases are divided, power are subtract. That's why e power minus 2x dot dx. Once again we can use here integration 1 dot dx. This goes up to the art number 1, formula number 1, and plus integrations e power minus 2x dot dx, and this goes art number 7. Okay, thank you very much guys. We will have assignment at the end of this tutorial video from the exercise 14.2. I am expecting to receive the assignment question number 21, 35, 38, 48, okay, 48, question number 48, 52, 55. There are only 6 questions, and you will have a 1 week's deadline. And in next class, integrations with initial condition will discuss. So hope you understood this video. If you don't understood, then please pause and go back, and once again you listen, then you will understand. Thank you very much. Bye.